it's just talking about parallel and perpendicular lines. These should be definitions that you've seen before. Parallel lines that are lines that are equidistant from each other at all points. They're never going to touch, right? So, so you guys are, I think, familiar with that. Perpendicular lines are lines that intersect to form a 90-degree angle. So I think you guys are also familiar with that, right? So what we're going to be doing today is we're going to be looking at what this looks like when we're talking about graphing lines like we've been doing in class, right? So what we're going to do for every one of these is we are going to graph the lines. So I'm going to do number 1, and then I'm actually probably going to skip and do one of the ones where you guys solve for y also, and then you guys are going to do the rest. So the first one, you may have already done this. We have a y-intercept at -4 and a slope of 2/3. So that's up 2 to the right 3. So if you have not already, graph this line. There. So this is y equals 2/3 x minus 4. And then I've got y equals -3/2 x plus 1. So I'm going to use a different color for that. I think I'll use green because I can. So I have a y-intercept of 1 from this number right here. And then my slope is -3/2, so I need to go down 3 to the right 2. Down 3 to the right 2. And so I should get this. Now, what I want you to do on each one also, which you haven't been doing so far, is I want you to take a guess if those are parallel, perpendicular, or neither. These are definitely not parallel. What do you think? They look like they're probably perpendicular, right? It looks like this is probably a right angle. Just because they're crossed doesn't necessarily mean they're perpendicular. Because if they look like this, they're not perpendicular. But I would go with perpendicular on this one. I think they look like they're probably perpendicular. Okay? If you haven't gotten there yet, skip over to number 4 with me. Because whenever you get to 4, they get a little bit more difficult to deal with. So if you haven't already got there, skip over to number 4. All right, Caroline, put that computer away, please. Thank you. All right, so I've got 2x plus y equals 9. I cannot graph that like it is. Okay, what am I going to have to do? Solve for y. So I've got 2x plus 3y equals 9. I got to get that y by itself. So I need to move the 2x over by subtracting it. So that gives me 3y equals y, 9 minus 2x. And then what do I have to do next? What do you think, Zane? Divide everything by 3. So I would get y equals 3 minus, this won't divide, so I'm just going to do 2/3 x. So, Zane, what's the y-intercept of that equation? 3. What's the slope? -2/3, so I'll go down 2 to the right 3. And so I'll have a graph that looks like this. Okay, questions so far? All right, Allison, help me with the second one. I've got 3x minus 2y equals 10. We're not going to add the 2 because the y is what we want to be by itself. So we don't want to move the y. Yeah, we'll have to subtract that 3x. So we'll get -2y equals 10 minus 3x. Divide by that -2. And so y equals 10 divided by -2 is -5. Here, 3 and 2 won't divide, but I do have negative over negative, which is going to be positive. Okay. So, Allison, what's the y-intercept of that line? -5. Perfect. And then, what's the slope? Other way. 3/2. Yeah. So, we'll go up 3, to the right 2. And we'll get this green line right here. What would you guys say for that? Parallel, perpendicular, neither. That one's perpendicular, it looks like. Okay, so I want you to graph all of them, examples 1 through 8 for me. Okay? Yep, examples 1 through 8. Okay. All right. Okay. No, Delta Math just has a random name generator on it. It's not as fun as the wheel spinning, but it already has your names in it, so it's quicker.
Can we do one of the ones I actually think I might know?
All right. Let's see. Let me get everything ready here. Okay. All right. So we did number 1 together. So everybody should have number 1. So we're looking at 2 here. Let's move this over. Let's see who it's going to pull for number 2. I want it. There we go. Okay. All right, Presley. Number 2. Bring the number 2 up here for us. Example number 2 from your paper. Bring it up here. Let's see what it looks like. It's not me. Delta Math did it. I'm sorry. It wasn't my idea. Okay. All right. So let's look here for 2.
It's
all right.
messed up. I know it is.
It's okay.
Because I did the back side of the other side.
Yeah, we'll prove it to everybody. There's some more work there. Okay, so let's look at 2 here. There we go. Okay. All right, so it is correct that they're going to be parallel. That is correct. So, Presley, tell me what's the y-intercept on that first one? -2. So we will go to -2 right here. And we'll put ourselves a dot, right? And then what is our slope on that? All right, so from here, what do we have to do? Over 3, like this. And I highly suggest going ahead and graphing that whole line before you start on the second one. Because if not, all your dots are going to run together and you're not going to know which one is which. So we got this line right here. Okay. Then, what's the y-intercept on the second one, Presley?
8.
Okay. So we got 8. And what are we going to do from that point?
Go up 1.
All right. Okay, so that will look, I think that was 4. That will look like this. Here, so would you guys agree? Parallel?
Yeah.
Everybody has one that looks like that, or if you don't, you're writing it down right now. Okay, Thank you. All right, let's see who's next. Zach, number 3. Okay, so here is Zach's. Let's see if it'll let me. There we go. Zoom in a little bit. There. Okay, so y equals 2x minus 3. That would be this line right here, this steeper line, right? You think that looks good? Y-intercept at 3, slope of 2, so it looks good. Has he got the second one right? Oh, no, Zach. Delta Math is evil this morning. He just knows everybody that has, it's like, it knows everybody that has a mistake. What did you do wrong on that one, Zach? You did a positive slope instead of a negative slope. So right here, we should have went down 1 to the right 2. And so instead of that line that he has there, we should have a negative slope like that. So you won't have this line here for that one. You won't have that line. So looking at this line instead of the other, would you say that they're parallel, perpendicular, or neither now? They look like they're probably perpendicular, so we'll fix that there. So we're 0 for 2. Wouldn't it be crazy if Delta Math only chose people with the wrong answers for the whole entire thing? Let's see. Let's see. All right, so now we did 4 together, so we're skipping 4.
Oh, I was going to say, if it's me, let me do 4.
Sorry. No 4. We already did 4. Okay, let's do 5. Marley.
Oh, no.
Let's see. Delta Math has been pretty brutal.
For 3 right now.
All right, let's see. All right, let's see. We got example 5 here. Okay. It's perpendicular-ish, maybe. Let's see. Let's see. You subtracted the 4x. You divided by -3. You got -4 plus 4/3 x. I think that looks good. We got a y-intercept at -4. We went up 4 to the right 3. I think that first line looks good. Second line, we subtracted the 3 and then divided by 2. So that gave you 2 minus 3/2 x. So 2, and you should go down 3 to the right 2. Okay, I think that looks all right. All right, I think our lines are graphed correctly. The question is do you guys think that's perpendicular? If I take the edge of the paper here and try to get it to line up, because the edge of the paper is a right angle, it's a little bit off. So you're really pretty close, but I think you're still slightly wrong, because I think that those should be neither for that. So Marley was close, but still had a little bit of a mistake.
I can't trust myself because I can't draw a straight line to save my life.
Yeah.
So I was like, it might be.
Yeah, we might should get out the rulers. Okay. All right, let's see who's next. Allison, number 6. All right, number 6. Okay. All right, let's see here. Okay, so this first one you don't have to solve for y, right? So you got a y-intercept at 8, a slope of -1. This line looks beautiful here. Okay, so you didn't write it. Oh yeah, you did write it down. It's just not showing on the screen here. So over here, you got to subtract the x right here, so you get 4 minus x. And so that would be a y-intercept at 4, a slope of -1. I think both those lines look great. And she said that they are parallel. Would you guys agree?
I agree.
Her lines are maybe not perfectly straight because it didn't pass out the rulers, but I think that they actually would be parallel if we drew them perfectly, right? So I think Allison is our first correct one. Good job. Yay, Allison. Okay. They're parallel. Okay. So good job, Allison. She has proven that Delta Math is maybe not out to get us. All right, let's see. Number 7. See who Delta Math is going to pick for 7. Ayla. Let's see if she can keep up the streak.
I hope I can.
I hope so. All right, let's see. So for 7.
My work's right there.
Okay, yeah, we'll show that too. All right, so let's look at this first because she did her work over here. So for 7, she had 3x plus y equals 9. She subtracted the 3x. Really, you could have just stopped there, but you're dividing by 1, so I think everything looks okay there. So that should have a y-intercept at 9 and a slope of -3. I think this line right here looks good. Let's see what she did for the other one. X plus 3y, subtract the x, divide by 3, -2 minus 1/3 x. I think that looks good there. And so we have y-intercept at -2, -1/3. I think that looks good. I'm pretty sure. Okay. She says they are neither. Do you guys agree? Okay. I think that looks good because that's definitely not going to be a right angle right there. Okay. So I think it looks good. Anybody see anything I missed?
Yeah, so you can give me another pass.
That'd be good if you give it. All right. I think she's right. Good job, Ayla. All right. And let's see who it's going to pick on last. Hey. You didn't even get 8?
No, wait, don't be pick no.
All right, bring what you got up here. You're going to help me as we do this one. It wasn't my idea. It was Delta Math. Oh, man.
Are they both straight across? Because I can put 2 lines.
Okay, let's see what he got. Okay. Okay, so y equals 9. Horizontal line at 9. Is that correct? Yes, it doesn't seem right that y equals is a horizontal line, but it is. It crosses the y-axis at 9. You got to go across here, so that's correct. All right, so this is a horizontal line at 2. Anybody think, is it right or wrong? Zach say no. What's he done wrong? All right, why would it be -2?
Because you have to move it over here.
Yeah, we got to subtract that 2 right there. So y is going to equal -2. So it is still going to be a horizontal line, but it should be right here instead. So Hank has been defeated by this problem. But, and would these be parallel, perpendicular, or neither? Parallel. They're still parallel. Okay. You were close. You had that almost right. All right, so we were close there. Okay, so what I want you to do right now with me is go back through and look at the lines that were parallel. Okay, so go back through. I can't flip here because I didn't graph all of them. But look through the ones that were parallel and look at the equations of the lines, specifically the ones once they're solved for y. So lines that are parallel. And somebody besides Owen, because I've already asked him this question, let me know when you start to see a pattern, something that's happening every time. Katie, what do you think? Slopes are the same. And there's one other thing there that has to be true you might not have thought about. I'll let you answer that one, Owen. That's have different y-intercepts. Because if they had the same y-intercept, they'd be the same line, right? So, on the slide that comes after this, parallel lines have the same, or you could put equal slopes. And I didn't put it on here, but, and we should put and different y-intercepts. Alright, so, perpendicular lines, I want you to look at all those for perpendicular. What do you mean by the switch?
Like, 2x plus 3y, 3x minus 2y, 2/3 negative 3 over 2.
Alright,
I
so
don't know how to
we had
describe
2/3 and negative 3 over 2. Those were perpendicular slopes, right? What was some of the other ones?
2x
2x and what?
negative 1/2x.
Negative 1/2 x. Okay? 2's not a fraction, but I could make it a fraction, right? And really, these x's don't have to go with it. So what's happening to the fraction? It's flipping it upside down. And one has to be positive, one has to be negative, right? They can't have the same sign, because if they both have positive slopes, there's no way they can be perpendicular, right? One has to be negative, one has to be positive. So there's some fancy words we're going to use for this. We're going to say opposite. That's not that fancy. But this next word's really fancy. Reciprocal. Have you guys heard the word reciprocal before?
Yeah.
When you're multiplying fractions, you multiply by the reciprocal. So what this means to do, opposite means to change the sign. And reciprocal means to flip the fraction. Alright, so whenever we are looking at perpendicular lines, we're going to have to flip the fraction and change the sign. Okay, if you don't have anything else written down on these notes, make sure you've got this copied down. You don't necessarily have to have these numbers down here, but make sure you got all this stuff copied down. So, instead of having to graph every line, if we want to know if lines are parallel or perpendicular, we can just look at their equations most of the time, or well, all of the time. Make sure everybody's got this down. See if you ever still right. Okay. Alright, so we want to find the slope of the line that is parallel to y equals 3x minus 4. Okay? What do we know about parallel lines? What do we know about their slopes? They're the same. Alright? So, parallel lines are going to have the same slopes. So, in this particular case, Presley, what is the slope of the line that's parallel to this line? Negative 4 is going to be our y-intercept. So it's going to be 3. So we're going to have 3 here. And it's only asking for the slope, so that's all we got to tell. Okay? Vince, this asks me for the slope of the line that is perpendicular to y equals 3x minus 4. So it's the same point, y equals 3x minus 4, or same line, y equals 3x minus 4. What would the slope of the line perpendicular to that be? 3 is the slope of this line, right? So we got to take 3. It is not a fraction right now, so how do I make it a fraction? Good. And so, remind me on that last slide, what did we say that perpendicular slopes were? What did we write down? Okay, so opposite means that we got to change the sign, right? So this was positive, so our opposite's going to be negative. And then the reciprocal, what's that tell us to do? Got to flip that fraction, so we got 1/3. So our perpendicular slope is going to be 1/3. Sometimes you'll see this right here, this symbol right here, an upside down capital T. That symbol right there means perpendicular. Mathematicians don't like a lot of words, so we create symbols to use instead of words, especially long words that are hard to spell, like perpendicular. So we just make up symbols for them. I didn't make this up. This is a standard symbol for perpendicular, so you can use it with any mathematician, and they should know what you're talking about. So perpendicular M is what you'll see a lot of times, because M is the letter we usually use for slope. So sometimes it'll be written like this: the perpendicular slope equals -1/3. All right, so Alyssa, for number 11, it asks us for the slope of the line that's parallel to y equals 1/2 x minus 4. What's the slope of the line that's parallel to y equals 1/2 x minus 4? Not going to be 4, because 4 is our y-intercept. All right, so we're looking at the slope. What's the slope of this line? 1/2. And then we know that parallel lines have equal slopes, right? So if this is 1/2, the slope of this symbol right here means parallel. We can use it if we want. Parallel. Just like two lines next to each other. So the parallel slope would be just the same. So we'll get 1/2. Okay, Julian, what about 12? It's the same line, y equals 1/2 x minus 4, but this time it wants us to give the perpendicular slope. What did we write about perpendicular slopes? What are they? You got it written on that slide? The one that said if you don't write anything else down? Opposite, reciprocal. So opposite means that we're changing the sign. So our slope here was 1/2. We got to change our perpendicular slope. We got to change the sign. So this was positive. That means our perpendicular slope is going to be negative, right? What's reciprocal mean to do? Flip the fraction. So instead of 1/2, what am I going to have? 2/1. And 2/1 is just 2, so we would say that the perpendicular slope is -2. That would be our answer. Okay, questions? All right. Let's look at 13 and 14. I want us to do this here. So, does yours have a negative right here in front of your 8x? Okay, I added that in. I wasn't sure if I added it before or after I copied it. All right, so we want to decide if these lines are parallel, perpendicular, or neither. So y equals 8x minus 4 is already solved for y. So what's its slope? It's 8. Peyton, what's its y-intercept? -4. All right, but -8x plus y equals 1, I can't tell till I get it solved for y. So Easton, tell me how to solve that one for y. It is a negative, yes. Okay, good. What's that going to give us? Okay, all right, is that solved for y? Yeah, it is. Because if we had a minus sign right here, then it would have a negative y and we'd have to keep working. But that's a positive y, so it's done. So what's the slope of that line? And what's the y-intercept? Okay, so are these lines parallel, perpendicular, or neither? What are we looking at to tell if they're parallel, perpendicular, or neither? Slopes, right? So the slope of this line was 8. The slope of that second line you told me was also 8. They don't have the same y-intercepts. If they had the same y-intercepts, they'd just be the same line, right? So they don't have the same y-intercepts, so since these have the same slopes, they are parallel. Okay, and if you think about it, slope tells you how steep lines are. So if two lines are never going to touch, they got to have the same steepness, right? Because if they have, even if they're off just a little bit, then they're eventually going to touch. All right, Passion, help me with number 14. Okay, that second one's already solved for y, so I don't have to mess with it yet, right? But that first one, I got 2x minus 5y equals 10. And I don't know the slope or the y-intercept of this line until I get it solved for y. So what would I have to do first to try to get that solved for y? Okay, just a 2. We're going to take away, but we're going to take the x with it, okay? Can I put 10 and 2x together?
I got it. And then we go 5, put 5 down, negative 5, and then equals.
The y right there, right?
And then 10 minus.
Okay. All right. Then
Divide it all by 5.
almost negative 5. So y equals
Negative 2.
good.
You can't substitute a negative 2x.
When I have negative over negative, it becomes a positive 2/5 x. So what I really care about is slope and y-intercept, right? So first thing I'm going to look at is slope. All right, so where this line right here was this line. All right, so we're comparing this line right here with the other second line. Passion, what is the slope of that line where we just solved for y?
2.
Mm-mm.
2x.
Number next to the x, so it's 2/5. So it's out of order, but it's whatever number's next to your x is going to be your slope. Over here, what's my slope?
2 over 5.
Also 2 over 5. So that makes me think parallel because they have the same slope. Are these parallel? No, why not? They also have the same y-intercept. Both of their y-intercepts are negative 2. So this is actually going to be neither because they are the same line. Now, sometimes they're just neither because you have a slope of 1/3 and 3 over 1. Right? They're not opposites, or 1/3 and 2/7. So sometimes they just are nothing. Here, they have the same slope, but they also have the same y-intercepts. This is the same line. I can't remember if I'm going to give you this worksheet this time or not, so I'm just going to go ahead and tell you. Another word you sometimes see on some worksheets here is coincide. Coincide, I think it's C-I-D-E. I think it's not inside like inside. I think that's right. So sometimes you will see this called lines that coincide because they're the same line there. So occasionally you will see that. Okay, questions? All right. All right, we're not going to do the writing equations yet. I do want to do one more of the perpendicular. Hold on.